In this lesson, we'll be looking at optimal values. That's often one of our important solutions to a problem. We want to optimize something, find the best solution. Really what it means is you're trying to find the maximum or the minimum of a quadratic, which is located at the vertex, in particular the y part of the vertex. You can tell if something's a max or min by looking at your direction of opening. If something opens down, well, you have to have a maximum. If it opens up, you have to have a minimum. If it's in the correct format, we can just look at our a value. And by the correct format, we mean is it in factored, standard, or vertex form. And a is obvious. If not, if it's not one of those forms, if it's out of order, well, you have to rearrange it. Or look at the x squared term. And the thing in front of it is always a. So we're going to try some examples here. We're going to look at different formats, trying to figure out which one we're in, because depending on which format you're in, it will tell you how to solve the problem. The easiest way to figure out the optimal value is this thing is in vertex form. Okay? Now, we're not going to go over that one, because if it's in vertex form, y equals 3 bracket x minus 1 squared plus 4, you should be able to tell the maximum really quick, because it's all right there. It's got a vertex of 1, 4, and it opens up. Oh, it's got a min of 4. I can see it in the equation. There's no math required, just thinking. Every other format, you have to do a little bit of math. Okay? Factored form is actually the messiest one, so we'll do that one first. To use factored form, we have to average our zeros. If I know my two zeros, I know my vertex is halfway in between them. So if I take the average, I can find the axis of symmetry. And then I can plug that into my equation and figure out what my vertex is. Okay, so to find our zeros, remember we got to set each bracket equal to 0. To average them, I'm just going to add them together and divide by 2. And then to plug it in, we'll just use our equation. So let's try some. Okay, find the min or max and when it occurs. So the first thing I need is find my zeros. That one's an obvious one, it's -4. This one's not so obvious, but I can solve for it by figuring out what makes it equal to 0, so 1/2. Here's my zeros. My axis will be the midpoint of these things. So I'm going to add them together. I'm going to change 1/2 to 0.5 divided by 2. I get -3.5 divided by 2, which is -1.75. That's where my max or min occurs. What is my max or min? I got to figure out the y value. So brackets, -1.75 plus 4, because that's what my x is. I'm replacing x with my axis. And do the same thing for the other one. And we're going to have to follow some BEDMAS stuff here. So inside the bracket, we'll get 2.25 in the first bracket. And then the second bracket, we'll get -4.5. And if you multiply those two things together, we end up with -10.125. Okay, so I've got the values. I need to figure out min or max. Now this isn't a great format to tell from, because factored form usually has a out front, but because I have x and 2x, I've got to figure out what the a value actually is. And it's 2, +2. Positive opens up. Up means I have a minimum. So here's how we're going to answer it. A minimum of -10.125. When did we get that? We got that when x was -1.75. Okay, lots of parts and pieces there to keep track of, but stuff we have done before. Let's try the next one. Find our zeros, find our axis, find our vertex, max or min. So zeros, I can't look at it, so I'll solve it. X is 20. My other zero, that's a nice one. X is 0. My axis, I'm going to average my zeros. 20 plus 0 over 2 is 10. My vertex, y equals bracket 100 minus 5 times 10 times 10. I'm replacing the x with the 10, right? Inside the bracket, I get 50. 50 times 10 makes 500. Okay, min or max, find my squared term. So if I were to multiply these together, and if I were to distribute that, I'd end up with 100x minus 5x squared. There's the a value right there. It's a negative. Negative opens down. Down means maximum. So I have a max of 500 when we got that? We got that when x was 10. That's our axis of symmetry. I think factored form is the messiest form to work with. I often prefer to change factored form into standard form. I think this equation right here is actually easier to work with because there's a little shortcut. When we have things in standard form, y, as in y equals ax squared plus bx plus c, the axis of symmetry can be found by that quick little formula, negative b over 2a. If I know that, well, once I know my axis, I can always plug that into my equation and get my vertex the same way we did previously. So I'm going to do the same question, just looking at a different form. So A, B, and C. I want to find my axis of symmetry by skipping the 0 step. So I'm going to take the negative b over 2 times a. Negative 6 over 6 is negative 1. There's my axis of symmetry. So A, O, F, axis of symmetry. I want to find my vertex. I can do that. 3 times x squared plus 6 times x plus 2. Everywhere I see an x, I'm replacing with negative 1. Make sure I do it with brackets, though. Okay, all into my calculator at once, or BEDMAS. Either way comes out to negative 1. The question is min or max. Well, if we look at our a value is positive. Positive opens up. Up is min. So minimum of negative 1, that's this one. When did that happen? We got it when x was negative 1. And you guys can try this one just to make sure. Axis of symmetry, x equals negative b. B is negative, so I can make it positive now. 2a, here's b, here's a. So 18 over 4, that's 4.5. Vertex, 2 times 4.5 squared. 18 times 4.5 plus 4. All into our calculator, we should end up with negative 36.5. Okay, max or min? Positive a. A opens up is min. So minimum of negative 36.5. And we got that when x was 4.5. Okay, so some basics, how to find optimal value again. We want this so we can actually solve problems. So a couple of word problems we're going to go over, things we've seen before kind of, okay, or refreshing for us. In this question we have Sid, he manages a shoe company. He knows that his costs can be modeled by this equation and his revenue by this equation. We want to figure out, what do we want to figure out here? The equation for profit. How do we find profit? Profit is made up of how much money we bring in minus how much it costs us to do things. So we can create an equation for that. Just be careful with our signs here. So our revenue is that equation minus my costs. Now, I need to put brackets on this to remind myself to subtract everything inside the bracket. So the equation is actually 22x and then minus 17 because I need to expand that bracket. There's our profit. How many pairs of shoes should he sell each month to maximize profits? I can find maximums by finding my axis of symmetry. That's in standard form, so the best way is using the negative b over 2a idea. Okay, so we get negative 22 over negative 4. He should sell 5.5. Now, in the question, it actually said that x represents the number of shoes in hundreds. So when we say 5.5 is x, this really means 550 pairs of shoes maximize the profit. As we have to interpret our answer. Part C. What is his maximum profit? So we know what he should do to create the maximum profit. We want to figure out what it actually is. So in other words, what's P at 5.5 using our function notation? So our P equation, we can replace all the x's with 5.5 and put that into our calculator. Let's see what we get there. I ended up with a value of 43.5. Again, we need to interpret that answer. Was that $43.5, or how was money being measured? It said, does it tell us here about how much profit? It doesn't tell us how much profit is. Okay, so, oh, yes, it does. In hundreds of dollars, right there, part A. Okay, so 43.5 hundreds of dollars. So what does that actually mean? That means the max profit, if we times that by 100, is $4,300. Okay, let's look at part D. Part D asks us for what happens if he doesn't sell any shoes. So in other words, what happens to our profit with 0 sales? Well, we end up at negative 17. Interpreting, we'll lose $1,700 if no sales. We put all the money into making those shoes and setting up the store. We don't sell anything, we lose money. And it's kind of a standard kind of question there. Let's take a look at the next one. Studies have shown that 500 people attend a high school basketball game when the admission price is $2. In the championship game, admission prices will increase. For every 20-cent increase, 20 fewer people will attend. What price maximizes profits? So this is one of our typical questions from grade 10. Okay. Our money, our revenue, is made up of charge something, a price, times how many things we sell. Okay. We know our price is $2. We know how many things we sell. Well, that's 500 people. So generally we make $1,000. $2 a person, 500 people. But we can change that. The question we have to ask ourselves is, how many changes do we want to make? So X is our number of changes. I can change my price by increasing it 20 cents. I don't know how many times I'm going to do that. I'm going to change it once, twice, 10 times, I don't know. I know 500 people will attend, but if I change my price, I lose people, 20 at a time, X number of times. Okay, this is kind of our standard equation we set up last year. They all look the same. I want to maximize this to get the best price. I have options. This is kind of standard form, or sorry, kind of factored form. So I could find my zeros and average them. Nothing wrong with that. Or I could FOIL this and put it into standard form and then find the axis of symmetry. We'll go through both just so we have an option here. If I want to find the zeros, I've got to solve this. 2x equals negative 2, 2x equals negative 10. That's one of my zeros. Oh, sorry, not negative 10, negative 20. Okay, my other zero, 500 minus 20x. So 500 equals 20x. X is 25. So my axis of symmetry will be negative 20 plus 25 over 2. Or in other words, 2.5. And that's one way of doing it, find my axis of symmetry. If you like the idea of using your zeros and averaging them, totally works. If not, another option, this is option number 2, is I could FOIL. Okay, so if I FOIL my equation, I end up with 1,000 minus 40x plus 0.2 times 500, 100x, and 0.2 times 20 minus 4x squared. Okay, if I collect my like terms, sorry, I have a slight mistake in here. This was a 10. Change our axis symmetry. Okay, negative 10 plus 25 is 15 divided by 2, which is 7.5. Okay. Right, back to this standard form version. So negative 4x squared plus 60x plus 1,000. Okay, my axis of symmetry in this method, x equals negative b, so negative 60 over 2 times a is negative 4. Negative 60 divided by negative 8, hopefully comes up to the same number, and it sure does. So either way, again, axis of symmetry is 7.5. I don't care which method you use, method 1, method 2, your choice. But the question was, what price maximizes profit? Well, our price comes from our initial equation. Initially, we were charging $2, but we're going to change that according to how many x's we need, how many changes to our price. So if I take my equation for price, and I plug in the number of changes, our axis of symmetry, I get 2 plus 0.2 times 7.5. The optimal price that we should charge, and calculate that, is $3.50. As I said, that's kind of our typical question from previous. And just giving us two options how we want to approach it. Okay, last question. Again, a typical kind of question. We have a rectangular field being divided, as shown. The farmer has 160 meters of fencing available. What dimensions give the maximum area? Well, we got to think of this as having parts and pieces. We got to put fences down all these sides, and down this side, and down this side. So we know that 4x's plus 2y's makes 160 meters of fencing, the perimeter of that. We're looking to maximize our area. Our area is made up of the length times the width, or in this case, x times y. When I have two equations and two variables, our objective is to substitute one equation into the other. Now I can't work too much with this equation because there's only variables over there. But the other equation I can rearrange and then divide out. And I know that I can replace y with 80 minus 2x. So over here, 80 minus 2x. Which if I want to expand that, I can write that as 80x minus 2x squared. Or in other words, I have an equation for area like that. If I want to maximize an area, don't I really want to find the vertex of that equation? So our axis of symmetry is helpful. Negative b over 2 times a, that's 20. Well, if I want to find the area, I can just plug that back in. My area is negative 2 times x squared plus 80 times x. Put it all in my calculator, and I get an area of 800. Now the question was, what are the dimensions? The dimensions that maximize area are, well, we figured the x should be 20. How do I get y? Right here at the top of the board, we said that y is equal to 80 minus 2x. Well, we just said x was 20, right? So we can solve for y. And if we do that, we get y is 40. And together, that gives an area of 800. Now, I did that by calculating it over here, but really, isn't 20 times 40 also 800? So two different ways of confirming that answer. Okay, so that's optimal value. Some things that we've seen before, mostly we've seen before, reminding us of things from previous. Quadratics is really important. Lots of the skills we use can be used elsewhere when we do math. So try some of these questions. If you're stuck, come see me.